Hello friends, welcome to Akul Mac Live, and today we want to talk about the applications of cable. And when we say that, normally we keep hearing about applications which are software applications, and what are these applications where cables can be so dynamic and so scientific. To discuss this matter, I will be joined by CEO of Toshniwal Cables, Mr. Naveen Toshniwal. Let's welcome him.
Thanks so much, Chandrakant. It's a pleasure to interact with you every week.
Naveen, welcome to the show. And in the past discussions, we have come to know about different kinds of thermocouples and how these cables can basically carry signals. And today, what is so interesting that you want to share with our viewers?
See, I will show you some specialized uh, applications. For example, in industries where you have high temperature zones or you require flexibility in the cable where a lot of movement is there in the machines. So how do we actually develop cables for these applications? So I can give you a small demo on that.
Sure, Naveen. So look forward to seeing these high-tech, cables that you are going to show to our viewers.
See, let us start with this particular cable. See, if you see carefully, this is a multi-pair cable. Very, very thin conductors are there. See, this is one pair, this is another pair, this is another pair, this is another pair. This is a four-pair cable and very thin conductor. I think the conductor size may just be maybe zero point 0.2 or 0.25 square mm, which is very thin. And then the insulation above this one, this green one, orange one, the different colors are for identification. This is of Teflon. Teflon is basically a brand name. The chemical name of the insulation is PTFE, polytetrafluoroethylene. So this insulation can withstand a temperature of 260 degrees continuous operation. So this cable can be used in areas where there is a high temperature continuously, like in the range of the boilers or furnaces. Plus, Teflon has got other very important properties, like they are moisture resistant and uh, they are also chemical resistant. They are resistant to almost all types of chemicals, and most importantly, Teflon is non-flammable. See, it is not fire retardant, it is non-flammable. So even if fire is applied to it, it will not burn. It will not burn at all. It will just probably give some residue of black color because of the soot of burning. But the insulation itself will not burn at all. So these are the special properties of PTFE or Teflon cables. And thereafter, you see there is a metallic mesh here. And we have discussed in the earlier discussions that this particular metallic mesh is for shielding purposes, for preventing the electrostatic interferences from other high voltage power cables to go inside and distort the signal efficiency inside. And then outside again we have a Teflon cover. So this is a Teflon insulated cable, shielded. Now shielding is of silver plating braiding. It is not tin copper. Silver plating is required in this case because when we apply the Teflon on the outer sheath, it has to go through a sintering process where high temperature of about 400 degrees is involved. So in the sintering process, if tin is used on the braiding, the tinning will melt. So we have to go in for a higher grade, which is silver plated copper. So this will withstand the sintering heat of the outer sheath. So if you see carefully, there is no blackening or no burning of the braiding here. It is looking very fine. So this is one of the specialized cables which we use as per client requirement. Now this is four pair. So in parallel, you are carrying four signals. So if you have any query, Chandrakant, otherwise I'll show you the next sample.
Well, I have just one query, and you mentioned about the silver coating to ensure that because silver is having a higher melting point, so that much logic I applied. But will it also help in shielding the cable when it is actually passing through a high temperature environment, or in case there is a fire? With this coating will help not melting the internals of the cable, or is there something else that is used to provide that property?
No, actually, silver is basically meant to cover the copper so that it does not burn or melt during the sintering process of the outer sheath. It has nothing to do with the electrostatic shielding. Shielding is done by the copper itself. The coating is just to give it a protection so that the copper is not oxidized, and if it is of tin, the tinning should not melt.
Fine, Naveen, I think I understand now. So what is the next sample that you want to show us?
Yeah, okay. See, the next one is this cable I can show you. This is a very thin cable. See, it is so thin. It is an oval shape. This is one side and this is one side. This is again a very, very thin cable, and you have this Teflon insulation. And then again, you have the braiding, the screening or shielding of braiding. And then again, you have the outer sheath. So, this thin cable is basically used in steel plants, where steel plants, we have to measure the molten metal. When you are measuring the molten metal, there is a lance which actually goes inside the furnace, and it is dipped inside the furnace where there is a dip type thermocouple. So this dip type thermocouple gives the reading, and then it melts. It is dissolved in the metal. So this cable is used for putting it through the lance, which goes up to the thermocouple to transmit the reading. So it is very thin so that it goes easily inside the small metallic lance, which is used for dipping in the molten metal. Now I'll show you another interesting sample. See, this cable is a single core cable. This is one copper core, and then you have one insulation and the second insulation. Now, this insulation is of silicon rubber. See, there are many types of rubber. Like this is a rubber which is used in normal applications. Like this is a ethylene propylene rubber, EPR. Then you have the outer sheath of PCP, polychloroprene rubber. Now, this is a very tough rubber. It is very tough and it has got very good mechanical strength. This silicon rubber has got the special property of being very flexible. See, I will bend and show you. It is very, very flexible. You bend it in any direction, it will come back to the normal shape. So this special application of silicon rubber is for high flexibility zone areas. So this is one insulation, and there is for protection, the double insulation is there. Of course, that is as per client's choice if they want one insulation or double insulation. But the most important thing to note here is the flexibility. And another important feature of silicon rubber is that it can withstand temperature of about 150 to 180 degrees centigrade. Of course, Teflon goes up to 260. Here, the temperature rating is lesser, but the important property is the flexibility, which you can see.
Yeah, definitely. I can see the the cable is very flexible, and there could be applications for this cable also. I have one question regarding Teflon, because you mentioned Teflon, and I know for sure that the electric switches in our homes are also made of Teflon. They are designed not to burn, but to evaporate into gas in case of a short circuit. So usually when we actually study our materials, we know that there is a melting point and there is a gaseous gasification point where it becomes gas. So with regard to Teflon, it straight away there's no melting point. It does not melt. It turns into gas directly without catching fire. So if this is a property of the material, how do you basically mold them in this thin coating tube shaped structure when it's very difficult material to work, I'm sure. Can you throw some light on that?
Actually, you are absolutely right, because you told me last time you were a physics student, so you already have quite a bit of knowledge on this. So what is the most interesting part is that this Teflon is not extrudable, remember. Teflon PTFE, polytetrafluoroethylene, is not extrudable. So what we have to do it, we have to make it in tape forms, slit it in tape forms, and then we wind through a taping machine. And after the winding, we pass it through a sintering oven. I was talking about sintering at high temperature. So when you pass it through the sintering oven, it will actually fuse and it will look like an extruded structure, but actually it is not extruded. You can still see the marks of tape on the covering. If you see very carefully, you'll be able to see the marks on the outer sheath of the tape. So it is not extrudable, as you rightly said. It is actually taped and sintered. There is another form of Teflon, which is FEP, fluoroethylene propylene. This particular material is extrudable, but this can go up to a temperature of 200 degrees, not 260 degrees. But as of now, and as per my knowledge, in India, extrusion of FEP is not very widely prevalent. Not very many people have entered into this field, or they are manufacturing it in India.
And I like the explanation about the cable which goes into the blast furnace when you say that when the steel is being melted, we want to take the temperature. This is a cable which is also a sacrificial cable, or it can be retrieved later on and can be reused.
No, actually, when we are dipping something into molten metal, obviously the cable will have a very short life, because every time we dip it into the molten metal, the cable which is near to the melted molten metal, that will actually be burnt out, or it will be blackened out, or it will be finished. So this is actually a consumable product. So you have to replace this cable whenever you dip it once, then you push the cable and move it inside the lance, and slowly when you finish one full coil of say 100 meters or 200 meters, you have to put in another coil on that. So it's a consumable process.
I have one more question regarding the molten metal. You may have an answer, you may not have, but I am presuming that you will have the answer to this question also. Uh, you see, when we make steel, the 2% variation of impurity, which is the carbon or magnesium, is very important when we talk about producing the type of steel for various applications. So, how do we measure how much impurity has to be added in molten iron ore in order to produce steel of various different types? Is there a mechanism that your industrial cable support in terms of measuring how much carbon is there in the steel, or how much magnesium or nickel is there in the steel? Is there a process which you can tell us today?
No, I think this is something related to chemical technology, and it is not related to the measuring of temperature through this cable. So it's a different sector altogether. Of course, the question is very interesting, but measuring the impurity is, I think, a totally different chemical process altogether. And it has to be done by the chemical labs which are there in the steel plants.
Fine, Naveen. I think we had a very interesting discussion, and we learned new things about the cable technology, because for a layman, cable is just a cable. It is a cable, a strand of wire covered with some sort of plastic or rubber. But I think so much technical stuff is there, and we are learning while talking to you. It is so interesting. Anything else you would like to share with us today? For example, you talk about temperatures. Can we use some of your technology and your cable in cold places also, if not hot?
Yes, yes. See, the Teflon can withstand a temperature even up to minus 40 degrees. So the temperature range is minus 40 to plus 260 degrees. So it can easily be used, but of course, this silicon rubber cannot be used. It will become brittle and it will break. Now, there is another type of insulation. See, this is fiberglass. Inside, we have Teflon. This is Teflon core, then there is a Teflon sheath, and then there is an outer sheath of fiberglass. Now, this fiberglass is able to withstand a temperature of maybe 400 degrees centigrade, and we apply a varnish on this. Why the varnish is required? Because fiberglass is in the form of rayons, रेशे हैं इसके अंदर, so they will tend to break even if you pull it. So when we apply a varnish, it will become very sticky and stiff, and then high temperature varnish, if used, it can even withstand up to 350, even 400 degrees. So temperature wise, it is even having a higher temperature range than Teflon. But the only point is that this does not have any mechanical strength. It is very weak in the mechanical strength. So even if you pull it like this, the fiberglass strands will come out.
So it is so interesting. I think for each application, there are different kinds of requirement and different cables may be required. And that is when the industries come to your expertise and your enterprise and they request for different types of cables. So it is so interesting to learn these things, Naveen. After talking to you, it's like an eye opener because for a simple thing like a cable, it could be so complicated also at the same time.
Yeah, actually, it is a very interesting field. And see, I am still keeping in touch with the studies which I had done in engineering college. Because, when you deal with so many special types of applications in different industries, and when I get an opportunity to visit them, I'm able to keep in touch with the academics and keep brushing my knowledge.
I have one very basic question, may not be related to the so far whatever we have discussed. Say, for example, in future, we would like to measure the soil consistency in case of farming, and as the technology is improving, there are more and more sensors being developed which can tell the farmer on his mobile phone what is the consistency of his soil, how much moisture is there in his soil, etc. So has anyone approached you to develop that kind of cable which can bring those in, that information from the field to some sensor and then eventually to mobile device of the farmer?
See, actually, the role of the cable is to transmit the signals from the sensor or the measuring instrument to the measuring point. So I don't think any cable can be developed as such, which can actually measure the consistency of the soil as you are talking about. But yes, the sensors, if developed, the signal transmission can be done through these cables, which we are already making.
And normally, what happens is that the now the signals are also getting into wireless space, wireless arena. Where that means the sensor will measure the whatever information it needs to process and send it through wireless, either through RFID or through mobile network. Do you see any threat in that arena when we talk about these new technologies which are emerging?
No, in fact, I have been hearing about these upcoming technologies and about transducers, which will probably reduce the demand of these cables. But I'm hearing it for the last 20 years. But I don't think there is any dearth of demand or reduction in the business. So I think this technology of cables will go on for many years now. Of course, the technology keep changes and it's changing, and we have to keep in touch with it.
Excellent, Naveen. It was a pleasure talking to you and learning new things about certain simple things in our life. So it was pleasure, and catch you next time again with something more interesting.
Okay, yeah, it was also a pleasure. Thank you so much.